Okay, hello everybody. Welcome to Loop and Learn's open mic tonight with special guest star. Oh, this is so much fun to say, Kenny Fox.
Okay, so what we can cover, this will be open, but we're gonna close the mic here for a second. We're gonna talk about one of the pages in Loop Docs that most people avoid because it has the word algorithm next to it. So I'm sure people either might scan it and never go back to it or just avoid it altogether. But basically, we're gonna talk about kind of why Loop or when Loop decides to give and take away insulin. And I will start by sharing Loop Docs because that's the easiest thing to do. Okay, so here's Loop Docs main page. You guys can see that, right? So what we're going to do is we're going to go to the operate section. And I gave you guys a link to this on the Facebook group, but you can go operate. And then this bottom section here on the left says algorithm. And then there's temp basal adjustments. So the first three sections are useful in that they talk about kind of a little bit of an overview, and then when Loop will recommend a bolus, which will that is important, and we'll talk about that here too, as well as how the glucose predictions happen, like adding food and insulin and how that works together to create that prediction line. Most of you have seen Loop enough to know that there is a prediction line of some kind that kind of goes out 6 hours. We're going to talk about how that line, in addition to correction range, will dictate when Loop will take action. Again, we're going to start with when Loop is taking action, not when you can take action, which is manually bolusing or even checking for a bolus recommendation. So you can see here, this says temp basal adjustments, and there is a note in here at the top, but I want you guys to think of temp basal adjustments as when we talk about increases, meaning Loop trying to give insulin. Think about that also in terms of auto bolus, since that's a feature now. This part of Loop Docs hasn't been updated to reflect that. So increasing temp basal is the same as an auto bolus, meaning times that Loop wants to give insulin automatically. Temp basal adjustments down obviously will be decreasing or choosing a temporary basal rate that is lower than your scheduled basal rate. So remember, everything's relative to your scheduled basal. So, all right, so as you can see here, it says Loop has 4 possible actions: decrease, increase, suspend, and resume. So I'm sure you guys can figure that out. Decrease is going to be using a temporary basal rate less than scheduled. So if you have a basal rate of 0.5 and Loop decides it wants to run a 0.4 unit per hour rate, that would be a decrease. Increase would be something more. So again, 0.5 going up to 0.6 or 1 unit per hour, whatever. Suspend is the term used for a 0 temp basal rate. So running a 0 unit per hour basal rate. And then resume is turning back on or re-engaging the scheduled basal rate. So those are the 4 actions Loop's going to take, every 5 minutes, every time it's looping. And you'll see a reference to auto bolus now. So same thing as increase. All right. So these pictures, which I can try to make larger here for you. So the pictures indicate a couple things. There's a lot going on. You can see the key over here. I'll walk you through it. Some of this should be sort of intuitive, right? These blue dots here on the left side is your CGM data. So blood sugar readings for the past, in this case, few hours. The star is your current blood sugar reading. So like right now, right? The dotted line is the prediction. Looks very similar to what it looks like in Loop. The blue bar here, you can see between right around 90 to 120 in this case, is the defined correction range. And then the star, the purple star, is the correction range target. So I think it's discussed in here somewhere, but essentially the target should be, if you're outside the range, Loop is going to try to push you into the middle of your correction range. So in this case, 105. The purple little bar there is the delta, meaning the difference between where Loop is aiming for you and where the blue star, which is the eventual blood sugar, is going to be. So Loop's trying to close that gap. Yeah.
That's an important point. So technically it does go to the middle, but as soon as you hit the bottom of that range, what happens?
Yeah, that's a good point here. I'm going to get down that in resume, but we'll call it out here because that's something you guys will be wrestling with in your mind the whole time. So this dotted prediction line, while this blue star is the eventual and loop is trying to get you to the purple star, once the blue kind of dotted prediction creeps its way up into the correction range, so maybe let's say in 5 more minutes, because loop reduced your basal rate, it thinks now you're going to be like 90, right, inside this correction range. That'll be more, you'll see in the resume section a little bit more. It'll be happy with that. So it's no longer going to try and shoot for the 105, that middle of the road target. It's just going to say, yep, okay, you're at target, which is fine. So its action will be taken based on the middle of your range if you're outside of it. But once your prediction kind of ends up inside that range, it's like, we're good. I'm not going to do anything different. And anywhere inside there, right? So just it's a good point. Suspend threshold is the red line here. In this case, it's defined as 60. And then minimum predicted blood sugar is 77. In this case, it's the red star. So that'll indicate the lowest spot in that prediction. And that's all these points here are all relevant to how loop decides when to do things. So in the case of decrease basal rate, so we're going to lower it. This one's
Kenny, can I
fairly
just jump
obvious.
in?
Yeah,
I have
go
a
ahead.
question because I've looked all over for the easier answers. Can you define the difference between eventual blood glucose and predicted glucose values?
The eventual and the predicted?
It's all over this document.
Yeah, okay. So eventual is eventual refers to the very last point in the prediction. So that 6-hour mark out here at the end, this blue star, whereas the predicted blood glucose can be anything along this dotted line, anything in between that 6 hours and including the last one. So they're often used interchangeably. We talked about the predicted glucose. Sometimes in the context of loop docs, you'll see that that's actually talking about the eventual blood sugar, but it could also be referencing anything along that point in time. Does that help clarify? Like eventual always means the last one. The predicted means anything in the line there. Good question. That's a great question, actually, because it is used a lot. Any other questions defining terms? This is a good time to do that.
I have a question. It's okay.
Okay, shoot.
I'm just looking, and I was a few minutes late. I apologize. I'm just looking at my loop, and maybe I'm missing. I don't have stars or this grid. I just have a line here. So how would I know?
Yeah,
what
good
those
point.
are?
So this is an illustration that's close to what loop looks like, but not exactly. The stars are more for your just to highlight some visuals here, to call out what the numbers are here in the key, and you'll see it used a few times down below. But you don't actually have stars in loop, right? It just changes from dots to a dotted line. There's no like star that tells you what your current blood sugar is. Anyone using free APS will have a small little vertical line there to kind of help identify where current blood sugar is. Same with these, like the red star. You won't see a red star noting this is your lowest blood sugar. You can touch and drag on that top graph, and it allows you to kind of cruise along that line, and you can kind of see where the lowest point would be in your current prediction. But you're right, there are no stars there.
Okay.
Good question.
Thank you.
Go ahead,
Yeah, I
Ellen.
have a question. The suspend threshold is 60.
In
which
this
seems quite
example,
low.
yeah.
I know an example. I'm just wondering, do people use 60? Because I used 80 because I didn't want to go below 80, but after reading all this, I'm down to 70.
Yeah, I know.
People go to 60?
I do know some people that are using 60 or 60s. I think in this picture here, it's more so that there's enough visual space in the graph so you can see things happening below the correction range while providing a reasonable correction range.
Kenny, it's an important point. Who would use 60? An adult who is an experienced looper?
Who's comfortable
young,
being in the 60s.
Yeah, who's comfortable being in the 60s. It is not for everyone.
No.
Nobody should feel like any competition to have the lowest spend threshold possible just to see if they can push the boundaries. That is not a thing.
Yeah, so my daughter, we have her set to 67, and that's more so we don't have her like her little dips in the prediction, making loop cut off basal suspend, which we'll get to in a little bit.
But Tessa's an experienced looper.
Yeah, her dad is an experienced looper, yes.
Yes.
Yeah, but I will readily raise it too. It's also kind of for me it was more like, okay, am I comfortable at night, which we'll get to example of why in the resume section. Am I comfortable with her hanging around 67, 68, 69, 70 while loop turns the basal back on, knowing she's going to come back up, assuming settings are relatively accurate? And the answer is yeah, I'm fine with that. So that's why I lowered it, because it helps with the daytime performance as well in terms of meals. But 70, 75 is perfectly fine. We have my wife's grandmother looping and her suspend threshold set at 90. So, it's fine.
Good.
Good question.
Thank you.
Yeah. You're not doing anything wrong if you're not using 60. That is a downside to these pictures, but it's more for visual white space kind of here. And people would, if you saw a correction range like 140 or something, people would be like, why would you have a correction range up there? So
Honestly, so that's a big jump, right?
Yeah.
What's that, 90?
90, yeah.
For the bottom, and then 60. 30 points is a big jump. I don't know, 15 points, 10 points is more typical.
Yeah, it's fine. However you guys want to run. We'll demonstrate why the correction range is important and why you might use overrides or set your correction range at a certain number going through here. Okay, so decrease. This is when loop says, hey, you're going to end up lower than your correction range based on the prediction. So loop needs to take action to get your blood sugar up. And the way to do that is to give you less insulin. So it's going to decrease the basal rate, use a temporary basal rate that is lower than your current scheduled basal rate to try and bring this up. Now, for little ones like my daughter, who's more sensitive, their ISF is higher on the higher range. More often than not, this results in a suspend as well, but not always. So when you have little ones running lower temp basal rates or scheduled basal rates, you won't see a lot of this, like something less than your scheduled basal rate if your basal rate's 0.2. It's just, and you're using an Omnipod. So that's just the way it goes. But you're going to be using a rate that is less than that, whatever it will take to restrict insulin enough to get you back up to this 105 target is the basal rate it's going to use. All right, any notice the minimum, so the minimum predicted is 77. It's not below suspend threshold, but it is below your correction range. But that's not really the highlight. The highlight in this particular why loop chooses to decrease is the eventual blood sugar is ending up lower than the correction range. Okay, any questions here? I'll move on to the next one. This one's fairly intuitive. Increase basal rate. So this, again, think increased basal rate, also equate this to auto bolus, okay? Not manual bolus necessarily, but auto bolus. And I'll explain why that's important later. Okay, so increase. This one's kind of extreme. And honestly, I don't see a situation like this very often, but in this case, the current blood sugar values and the prediction, the lowest point in the prediction and the eventual blood sugar, they're all well above the correction range, right? So in this case, loop's going to take action to give you enough insulin to bring this prediction down to, again, the center, 105, of the correction range. So yeah, so that's what it's going to do. So because everything is above the correction range, so you're going to get more insulin. Now, based on the description here, if the eventual blood glucose is greater than the correction range, and here's the and all of the predicted glucose values are both above the suspend threshold, so above the red line, right? And equal to or above the correction range. So that means it can be in the correction range. So essentially, if this dotted line, if the prediction that you have, that you guys see in loop, is above suspend, and your eventual is also higher than the correction range, then it's actually, this probably should be adjusted a little bit, but if it's in the blue, and above the blue, so if any of it dips down, if this red star was like 100, was inside this blue section, and then your eventual was still up here, loop would give more insulin. So it's going to do it automatically. And I think actually some of this language might need to be adjusted, and we'll talk about that here in a sec. So that kind of makes sense. You're eventually going to be higher than your defined correction range, and your whole predicted values are either inside this blue or above it, then it's going to do stuff. And obviously not above suspend. You wouldn't want, we'll talk about that one next. If this prediction goes below suspend at all, we're not giving you any insulin. We're just cutting it off. So we'll go to suspend. This one's super easy, right? You guys have seen this one happen a lot. In any part of the prediction, doesn't matter if it's the eventual, which is probably more common, or if it's a point in the middle. If any point in the prediction goes below suspend, and really what's happening, if you want to look at the code, it's actually looking for the lowest point in this whole list of values in the prediction. And if it says is the lowest point, where is it? And then is it below suspend? If it is, then turn off insulin, 0 units per hour. Anyone having questions on this one? This one's pretty simple. Okay, now we're getting to the fun one, and I'm going
Hi,
to try
Kenny,
to bring
I
up.
just unmuted. So
ahead.
we just one thing that I think a lot of people think about when this happens, they look at their prediction line and they see it going down below and like, oh geez, I need like 85 grams of glucose. Now I know tonight we're not talking about treating lows, but what do you have to offer on how to interpret this and what action you should take?
Okay, so something to pay attention to on this page, the way these pictures are illustrated, these pictures are actually illustrated, I would say, more for that time right at the looping, right? So we get a new CGM value, and then this is reflecting what loop's prediction is in that moment, but before it takes action, before the loop is complete, and then it like actually does something. It changes the basal rate or bolus or whatever. This is that in-between time is what I would imagine these pictures to be used for. So we got a new CGM value. If you ever had loop open, you can see it when the value comes in, the prediction changes, then you might see this like pulsing of your loop, and then loop does something. It changes, it either gives you a bolus or it reduces your basal rate or turns your scheduled basal rate back on. It does some action. And then the prediction changes again. So if you ever have loop open and you see that happening, that's what I'm talking about. Is so before it takes its action, but we just got a fresh CGM value in, this is the prediction you're looking at. So hopefully, like in this case here, the eventual line or the lowest prediction is just skirting the suspend, right? And still aiming a little low. So loop's going to reduce the basal, but in this case, it's going to cut it to 0, and then the prediction is going to adjust. So hopefully you don't see something like this. But if you did, and you were someone who was comfortable with a 60 suspend, then you're probably relatively comfortable with a eventual of 65, knowing that loop will keep adjusting later. So like in another 5 or 10 or maybe 20 minutes, loop's going to maybe turn off the basal again. And then that prediction will go up a little higher because it's going to take away more insulin. So in a lot of cases, the prediction may not be exact, and you're going to have to get comfortable with where your settings, like how close your prediction kind of comes true or doesn't. And also if you, the person, know that there is something that you're going to do or that's going to happen that maybe loop doesn't know about yet. Like, you're going to eat soon. So this prediction doesn't really bother you, right? If you're coming up on dinner, then you might just roll with this and maybe just won't pre-bolus as much, right? So there wouldn't be any panic necessary. If you saw this drop and you maybe been fighting lows all day, like you can see this prediction here, the blood sugar kind of skirted around 70 and then went back up and then went back down again, and maybe you treated here at 7 a.m. in this particular picture, then your settings are maybe a little bit off, and you might be fighting some lows, then yeah, I would take some action, right? Those are kind of my two obvious ones. As you get used to your settings being right or not in terms of the prediction, you'll get a feel for maybe when you should take action and when you shouldn't. I would always, in general, unless there's like a fast drop and you're being active, or that fast drop shouldn't be there and it looks like it's going to continue, then you might take more dramatic action in terms of treating a low. But in general, what you want to do is get comfortable treating lows with maybe just a couple of grams of carbs. Pick something you can use regularly and kind of understand how your body's going to react to a glucose tab or a couple ounces of juice or something you can replicate pretty easily. and bump gently, especially if you're a new looper and you're seeing kind of these, what you see in this picture here, kind of a gentle, fairly gentle blood sugar modulation, is try and bump as gently as is reasonable to let things play out and see if loop maybe would have caught it, or maybe just keep it handy, right, until you get low enough that you think you need to treat. I think you'll be surprised. I think a lot of new loopers are, and I was when we started, just how often a low is prevented by simply turning off the basal or reducing it, ahead of time or at some point in the day. Because when you start and you're just pumping, you're not really turning basal off very often manually to kind of see what happens. I was, but that's because I knew that we were going to move to looping and I was reading up on the docs. I'm like, well, I guess loop turns stuff off, occasionally. So if I see a low coming, I'm going to try doing it when I'm, on weekends when I'm home and have my daughter's PDM handy, and saw that you might catch some things a little more often. So that's my general recommendation. I'll go to Ellen, and then Carol, you can add any color you want to add. Go ahead, Ellen.
So this prediction curve, does it assume that loop has cut your basal down? Because I've had lows like that, but then it seems like loop is, taking away basal. And so I never hit the low. So is this prediction curve based on what loop is going to be doing for the next 3 hours, or is it based?
So that's a good question. So whenever you see a prediction line in loop, it's reflecting the current state of things. So let's say you had this particular prediction you're seeing here where it's dipping below suspend, and so loop has suspended insulin. You're at 0 units per hour at the moment. Remember that loop always sets a 30-minute temporary basal rate. So its prediction will be based on, let's say it was just set recently. The prediction will be based on running a 0 unit per hour temporary basal rate for 30 minutes. That's the reflection you're going to see, the prediction you're going to see in loop. Then 5 more minutes goes by, the prediction will adjust. Hey, there's a little bit less insulin on board. Maybe the momentum and the angle of your particular blood sugar readings is changing, and that adjusts the reading. Maybe you went up a little bit, and so now loop is decreasing the amount of active carbs in your system, whatever it is. As things will change every 5 minutes, it will adjust, but it's doing it based on what it knows. So that includes the temporary basal rate. If there's 5 more minutes left on your temporary basal rate and you're going to resume your scheduled basal rate in 5 more minutes, that's the prediction that you're seeing is based on that information. Now, that said, there is the code in loop says, okay, if there's 10 minutes or less left in the current temporary basal, and the prediction is still requires a suspend. Let's say you kind of have this suspend kind of situation here that's lasting for 30 minutes or an hour, whatever it is. If at 20 minutes, so 10 minutes left in the temporary basal of 0 that it set just a little while ago, it still says, yeah, I need to suspend, then it's going to refresh that particular temporary basal rate. So at 20 to 21 minutes, it's going to say, okay, let's do another 0 unit per hour for another 30 minutes. And then the prediction will change based on it turning off for 30 more minutes. Now it only ran 20 and then refreshed it, but that's what the prediction states. Does that make sense? It doesn't always see how long, but
no, that makes a lot of sense. So every 30 minutes, it's going to take into account the fact that the next 30 minutes there'll be 0 basal. So my chances of hitting that low are pretty small because I've
become
got
less and less.
Hours,
yeah,
becomes less. So you don't really need to worry about that if you've got 3 hours until it happens.
Yeah, if you have a pretty steady kind of graph like this is here, not a whole lot of insulin on board, just a little bit, maybe not many carbs to deal with, like kind of this picture here, it doesn't really talk about the carbs and the active insulin at the moment, then yeah, a gentle kind of prediction like this wouldn't concern me, especially even with food on board. If generally speaking, we do fine with loop the way the settings are at the moment, and a little bit of a skirt under suspend happens in terms of the prediction, I don't usually bother to do anything. I might keep an eye on it, be like, oh, okay, that's fine. Meals is a whole other conversation, but yeah, that's correct. Go ahead, Carol.
Thank you.
The only other thing that I was going to clarify is, but loop is rethinking all this every 5 minutes.
Yeah.
It's very complicated, and we're all lucky to have the developers that we have because they're thinking about things that the rest of us wouldn't.
Yeah, so it's updating, like I said, kind of everything that it knows. Momentum of the blood sugar. We have all the elements. If you guys have taken the quiz about what makes up the prediction, all those things adjust every 5 minutes or so. But yeah, the prediction is based on what it knows, and then including the currently running temporary basal, if any. All right, cool. All right, here we go. Top one's easy. The next one down is kind of where the magic happens, and we'll answer a lot of questions a lot of people have around, there's a recommended bolus and Loop's not giving it. What's going on? We'll get to that in a second. So teaser, here we go. Okay, so resume basal rate. This just means turn back on the scheduled basal. Run the scheduled basal rate. Everything's happy is kind of this first example here. And you see that the current CGM reading is actually inside the prediction range, the correction range, and the lowest point in the prediction is inside the correction range, and the eventual is inside the correction range, and then like kind of its target, which is the middle of that correction range, is there, but it's not really being used. There's no, because the eventual blood sugar is within that range, Loop is not taking any corrective action to get you to that 105 because you're inside that 90 to 120 kind of blue area. So that's pretty simple. Like, it's nice if we saw this more often, right? You can also see this is kind of one reason, especially once we get down to this next example, we can come back up to here and you can rethink this, but this is why a wider correction range often means Loop will kind of let things happen a little bit more. It's less aggressive to get you to that spot, whether it's taking away or adding insulin. Because when you go down to this one here, this is a good example. When you're, one reason we need to fix the language, I think, up a little higher, but the eventual, the lowest point in the prediction here, you can see the current CGM reading is inside the range. The lowest point is below the range, but above suspend. So we're not necessarily turning insulin off, and the eventual blood sugar ends up high. So looking at this, I'll ask someone a question. If you were to hit the double arrows, the bolus button, would you see a recommended bolus in Loop in this situation? I'll just give you guys a second to think about it. Does anyone want to type in the chat what they think the answer to that question is? Will Loop recommend a bolus in this particular situation? Any bolus? Actually, I should bring up chat and actually look at it, huh? Let me get Somebody says no. See some yeses.
It's a definite maybe, Kenny. I've been looking at these
maybe.
comments and it's definite maybe.
All right, we have an average of maybe. That's fantastic. Okay, so the answer is yes. If you were to push the bolus button, you would actually see a recommended bolus to bring your eventual blood sugar closer to this target range. Now, I'm not going to dive into this too deep, but to say that the recommended bolus would be enough that it would bring you down to range, unless this the red star here would put you at below suspend. So Loop will recommend as much insulin as it can that still keeps you above suspend when you manually check for a bolus. But will Loop actually give you the insulin on its own in an auto bolus or an increased temp basal? The answer is no, because again, we're under the resume section. It's simply going to turn on your scheduled basal rate. It will not give you any extra insulin on its own to bring you down.
But it will let you do it and will tell you how much.
Yeah, it will tell you how much. And on the bolus screen, you will see a little bit of a warning that will say your prediction. I wish I had a screenshot. Sorry, I should have prepped for that. That will say your predicted glucose values is below your correction range, as a warning on the bolus screen. But you are still able to give that bolus. Like, that's your choice to give it or not. But Loop will not do it. So this is where it deviates between what Loop will do automatically versus what it will let you do manually. And so,
right, really where that 15-minute timer comes in handy, right? You set a 15-minute timer, take another peek. Are you willing to push the button, even if Loop won't do it for you, right? You just had some nachos or, a sandwich or whatever. Loop doesn't want to deliver it, but those 50 grams of carbs are going to come skyrocketing through. Do you want to preempt it? Because Loop will not.
Correct. So another example of this. Here we go. So maybe a more common example, I'll zoom this in a bit, and then we can look at this. I'll share the screen here. Here we go. So here's a picture in Night Scout, and I drew on it the blue correction range, right? So you guys can see the blue bar here. Now what you'll see that this person ate 20 grams and entered it while they were low, kind of under 70. It's actually a child, but it's more common like at lunch or something like that at school. But so they entered 20 grams, and Loop predicted, I didn't grab screenshots of this necessarily, but Loop predicted the little purple prediction line in Night Scout was going to go high, right? That makes sense. 20 grams is a decent amount of carbs. So you would expect that without a bolus, Loop would predict a high, something higher. But we set the correction range up to, I think she set it up to like 140 or something like that. So I tried to draw where that correction range was here as our own little blue line. So you'll see that while Loop predicted a high, and if you hovered over the Loop pill or checked the two orange arrows, you would have seen a recommended bolus. It basically in all of these green dots here, at every point in these green dots, you would have seen a recommended bolus of some kind. But Loop didn't give it because the correction range is set all the way up here. And this is in the resume category. So while the last picture showed the current blood sugar kind of being in range, I think more common what people see is maybe starting a meal or something like that, where the current blood sugar is actually below the range. And that's the offending value, is the current blood sugar is actually your lowest point, right? It's maybe below suspend or something like that, or below the correction range, even not necessarily below suspend, but under your correction range. So don't you have to be hypo, you just have to be under the defined range. So if someone had a defined range of 110, if it was down here, Loop still wouldn't give any insulin in these dots, right? It would wait until here, till it enters, until the current blood sugar and the whole prediction is in or above that correction range before it tries to give any insulin automatically. So you'll see here that once the blood
That's such
sugar
an
value
important
is,
point. Like
Go
that
ahead.
is such an important point, right? You've got to be within the correction range and above the suspend threshold for the whole
thing,
6 hours.
the whole dot to the whole 6 hours.
So
This
many
one's
questions
easier
on
to
this
see.
exact point.
Yeah, exactly. I see this all the time, especially with the kids at school. Like, hey, they've entered the carbs. Loop didn't recommend a bolus. Now they're going up, and there's a recommended bolus, but Loop's not giving it. Why isn't Loop giving it? And this is why, is maybe you have your correction range defined in like the 100, 110, 120 range. So as they come up from 70 to 75 to 80, now the food's getting ahead of the insulin. You know that's not great, but Loop's not giving the insulin automatically. And that's because
This is such an important
great.
point too, because
Oops,
people
I
are
hope I'm
too
not online.
insecure to go ahead and give that bolus a lot of times if they don't understand that what's
Right.
happening.
Right. And you're welcome to do that. Again, Loop will recommend a bolus along the, like I said, this whole green section. So if you have your child check for a bolus, it'll be there and they can do it. But you can see Loop started giving the insulin auto boluses once they entered, once the current blood sugar and the rest of the prediction entered the blue correction range here, and then it kind of and gave all the insulin. Now, here's the other trick is that what you can do is you can set this is where temporary overrides, and you guys might see me talk about this a lot in the group, is using temporary overrides that only change the correction range, right? Why that's so powerful is exactly here. So if I set a temporary override, that is like I have one for my daughter set at like 70 or 71 or something, like just above the suspend. I use that for situations where I know she's going to be at recess. She's going to kind of be dropping, and then she's going to enter her lunch carbs. And Loop's probably going to hold a bunch of insulin back because she's falling. Momentum is pushing her below suspend, or at least close to it. And as soon as she starts trending back up, I know 1, she's done running, and 2, she's already eaten her food. So I want to make sure that insulin gets in as soon as it can, but I don't want to be babysitting it. Even though we're using Dev and I have the ability to remote bolus and all of that, I'd still rather not worry about it. So I just set a temporary override with a low correction range, or you guys can use the pre-meal if you're the one actually looping and not doing it remotely. That has a nice low range, like down here. So then once I know she's coming up above a certain number, the range I've defined, then I say, okay, Loop, now you can start giving insulin. rather than waiting to her normal range, which for my daughter's kind of right here, I bring it down to here. Or for this person, it was here, and now
that's
she
why
might want to bring it down.
I'm here, then they'll get insulin.
Yeah, exactly. So there you go. So that's why adjusting the correction range is very, very powerful. Just by itself, without having to feel like you need to do a 200% override or a 50% override or a 150 or a 110. Like just move the range temporarily. And I have mine expire after about 60 minutes, for example. It's not very long. I just know that she's starting to eat and she says start turning up here.
This
in a
is
little bit.
exactly what you and I were talking about, Rob.
So, all right. So Ellen has her hand up. Yeah. No, you're muted. No, you can unmute.
So sorry. You just answered my question, which is how long the override should be. Because
Oh,
I
yeah.
see this happen a lot. If you're, at 75 or something, when you're going into a meal and your range is 100 or 105, you can't get the insulin you need. And so you start going too high.
Yeah, 30 minutes, an hour, 2 hours, whatever. It doesn't need to be indefinite. It just needs to be probably, I mean, at least in this case, you wouldn't necessarily want it to be running a 71 target, all day, every day. So,
Right. So an hour would probably, because Loop gives you a certain amount and then you keep getting more for a while after a meal. So probably
correct.
an hour or two is good. Okay. Thank you.
Yeah.
You
And
know
then,
what? And we never do that. We just set a 15-minute timer. And as soon as we start to see it tick up, we go with the full bolus.
and
So
you can have,
there's a whole bunch of strategies on this.
yeah, exactly. I mean, for your kiddo, they're probably not paying attention to any of it. So,
And so we have a bunch of adult loopers with us tonight.
yes.
So Carol, you just use what Loop recommends. Is that what you do? So if you're like, you go into Loop and see.
So you go into a meal with negative IOB, like blood sugars in the toilet. Yeah, I would set a 15-minute timer and I would dose as soon as it starts to go up, I would throw in some insulin, not the full thing necessarily, enough to get rid of the negative IOB and to thwart that rise.
And are you using the amount that Loop recommends then?
No, I might throw in a couple of units. It depends, maybe 30%, 50%.
Half of what
And
Luke
then-
recommends. Yeah.
Right. And then ratchet it up again.
Because again,
Okay.
Loop will recommend something earlier than it will take action in the case of coming from low to coming up, because your correction range is probably a relatively safe range. But you knowing food can be faster than insulin, you probably don't want to wait too long to give insulin if you can avoid it. So you can also have a situation where I'm illustrating here where you have multiple correction ranges defined. There's not a good picture of this in Loop Docs. I have some that I was building for a video and I couldn't find them easily this afternoon. But so multiple ranges, this affects what we're looking at with that predicted line. So take this same idea here where you might have a couple hours of a lower range and a couple hours of a higher range, but instead apply that here to this kind of a situation where you're thinking about how this interacts. If you cut these blue sections around and like cut them in half or move them up and down, you'll see that all these rules apply, that when it's paying attention to correction range as it's like it's defining range as to whether or not it should simply resume basal or give you more insulin, for example. That's important because it covers that whole 6 hours. So we've had a couple of posts in the past that be like, well, why isn't Loop giving me insulin, or why is it trying to give me insulin? And it was because they had a correction range at this level and they had another one in the future in like 3 or 4 hours turning online, down here like this, and so down in a lower range. So Loop was aiming for that lower correction range. As eventual blood sugar was shooting for the correction range at 6 hours out. That's where it's looking at the eventuals. What correction range is active at that eventual blood sugar? But then all along the prediction, that whole 6 hours, which correction range is active at which point in this process. So if you had another range here defined at 2 p.m. that was actually lower, that was, let's say, kind of 80 to 90, maybe from 2 to 6 in this particular situation here, then you would see the Loop would maybe do something different. It would actually give you insulin because your eventual is going to be higher than your correction range, and the whole prediction's inside that range. I guess I could take a picture and illustrate that. I
personally think that multiple correction ranges hurts my head. It's like quadratic equations when you're a college senior. If you're not a math major, it hurts And so I don't recommend them from anybody. Like you're Kenny or Marion, do what you want. The rest of us, it seems like it's just too complicated to try and figure out what's driving your results. If you've got various basals, various ISFs, various carb ratios, and multiple correction ranges, who knows? It really does sort of, I know Kenny can sort it out. Most of us cannot.
Yeah,
Yeah,
you have to think about it along the points in time, which is it's just tricky. Like I'm not gonna lie. That's
I'll throw one in, a while before swim team practice, and then it'll get cut off when we go into swim practice, so it's not something that Loop is shooting for long range. It's kind of a little blip on the screen.
Yeah, so you might see something like this. If your correction range was expanded to go down this low, then in this situation, we wouldn't be in a resume situation. We would be in an increase situation where Loop would want to add insulin automatically. If your correction range was expanded to cover the bottom of this particular prediction, this scenario you're seeing here. So that's why that's important. Now, a temporary override, keep in mind, even though in my example I just gave, the Ellen asked about, maybe run a 70 to 75 kind of correction range as temporary override, but only for an hour. When temporary overrides are engaged, what that does is that overrides the whole 6 hours. So while visually in Loop it may show that it's only going to run for an hour, the Loop is acting as if it's a full 6 hour correction range. So these rules that I'm showing you right here don't apply when you're talking about a temporary override that is a correction range change. It's saying, I don't care if the temporary override is scheduled to run for 30 minutes or 3 hours or indefinitely, it's going to treat it as if it's going to run for at least 6 hours. That range is applied across the whole history, even though it will expire eventually. Loop's not taking that into consideration at that moment. So that's something to remember too when your temporary override correction range changes are being used. Okay.
I have a question. And I know this comes up a lot. I happen to be experiencing it a lot today. Some major roller coasters. So, I don't want to go into too much detail. I don't mind sharing what happened to me today. It's not a big deal if it's going to help others. I just don't want to share it if it's going to take away from the program. So,
Well, how about this? Let's check and make sure if we have any questions about this particular topic, because I'm at the end of it. So then now it's going to be open mic and we talk about whatever.
okay.
Anybody else have any questions around increase, decrease, suspend, resume, and how the correction range sort of plays into this? And again, you guys can come back and look at this page. I came here a lot for a while, try to figure out like why Loop is doing what it's doing. And this helped me to say, okay, this is how my situation applies to these graphs. And again, I feel like we need one more example of this lower one where your current blood sugar is the one that's actually below, because that's what people see the most. But any other questions? I think Helen's got her hand up. Digital and physical hand up.
You said that if you set up a temporary override for 1 hour, Loop looks at it as though it's on for 6 hours.
Yeah, the
what does
whole
that mean?
duration.
They're
So
looking
as
on this for 6 hours, why does it do that? And what does that mean?
it just means that for its entire prediction. So let's let me see if I can draw this. So if I draw my little blue square here again. Can I do a dotted square? Maybe that'll be helpful. Let's try that. Okay, so let's say we had another range here. Let me
take it apart tonight.
then do another one that's white.
One more night, and then in the morning I'll take my babies out and I'll clean it out for the babies.
So let's do this. Okay, so now we have two different ranges, right?
Give me some.
So we have two different ranges here. Now you'll see that Loop will behave based on like along this prediction line. It'll take into consideration this lower correction range in terms of its action. Now, when you go back to the picture we just had, just one range all the way across, that's what it's going to do. It's going to behave as if it's the full 6 hours. Now, a temporary override changes this to go from the range you've defined to, even though I've only set it for an hour, it looks more like this. Oops, not white. That's not good. White doesn't help you. Sorry. Blue. Pick a better blue. There we go. All right. So even though it's set for an hour, visually in the loop, you might see it looking like this. And I'll white out the rest of it. You might only see it visually in loop as like running for an hour, but how loop will actually behave is it will actually behave as if it's the full 6, and it will ignore this old correction range that's kind of defined in the background. It'll take your override and say it's right now. It's overriding everything. It's overriding the correction range you have defined as well as the future ones you have defined. It's saying this is it. This is the override. I'm overriding all the things. This is the range you're using no matter what. No matter if there's 75 correction ranges defined into the future, when you set an override, you're saying forget all that and just pay attention to this. One,
But
it's
only for the time
simple.
the override is on. This is a very
Yeah.
important point. I'm sorry, Elena. Yeah, this is a huge, this is like our second huge point tonight.
She gets gold stars.
So, yeah, well, no, so I just want to make sure I understand. So when I put an override on for an hour, I know my basal, let's say it's 80% is cut down 80%.
Mhm.
But are you saying loop will actually keep it at 80% for 6 hours or just for
No,
the hour?
it will act as if that's the
The goal.
now we're getting into your basal needs. It will act as if your basal needs are at that 80% range for 6 hours, but then once that hour expires and it flips, it turns off. Now it goes
Right.
back to assuming your basal is 100% normal
Okay,
rate.
so it's
But
just for purposes of prediction that it assumes
correct.
6 hours, but not in terms of
Prediction
what
and
we're
action,
doing.
both. Yeah,
Oh,
prediction and
action?
action. Yeah, like the actions we've talked about here. So when you set an override, this is a little harder to illustrate. When you set an override of 80% with no defined target or correction range change, it uses your current correction range. So let's say let me draw this. Okay, so let's say you defined 2 ranges, right? You got this first one and then the second one.
Mhm.
That's like your normal, that's what's set up in loop. But you turn on an 80% override that's going to last. Let me pick a different color. I'll just pick purple. Why not? You set an override that's going to last, maybe this long, right? So this is how long your 80% range is going to run. What loop will do during, I have to pick another color. Sorry, it's gonna be very colorful here. We'll do green. Okay, so during this section here, let me make it dots. During this section right here, while you have the 80% override on, it's going to say, hey, the scheduled range, which is the 90 to 120, is actually 6 hours. It's overriding, it's taking your current defined range because you didn't type one in the override. It's taking what's scheduled right now and it's saying it just applies all the way down the line. It's ignoring the fact that you have a second range defined later. It's a nuance that isn't usually super relevant because most people don't use a lot of different ranges, but sometimes parents try to use the ranges more for like different activities at school and they don't get quite the effect they're looking for. And then an override changes that again. So whatever the range that's scheduled is, if you don't define one in your override, it takes that and it says it's 6 hours. Again, so it's ignoring this lower blue range that happens later because during an override, that's what's going to happen. But then once you get to do another color, all right, more colors, here we go. Let's say now you get to here, this red section, now it's going to take this lower range and say that's applied for 6 hours, right? It'll switch once it gets to that time, but an override uses the current scheduled correction range as forever. It doesn't try and play the game where like, oh, well, you have a future range that's lower and now your prediction goes down and that's okay. It's not looking at that. It's just like override means override. Like right now is right now. So unless you define one, it uses whatever one is scheduled. So that can cause some different behavior if you're expecting, for example, a nighttime override. I have set a slightly lower range overnight for my daughter than we do during the day, from like midnight to like 1 or 2 in the afternoon. Like midnight to noon is kind of an easy way for people to think about it. But if I turn on an override, it's a little more aggressive in the morning. If I turn on override at 8 a.m., it's gonna target that lower overnight range as if it's present for 6 more hours, where in reality I have that correction range changing by lunch. And so that changes what loop would normally do. So if I didn't have an override on. So it's very subtle differences, but it can mess things up if you're not expecting. Once you figure out all this stuff we've just talked about, and then you're like, hey, it's not doing that. Well, it might be because you have an override on and it's not looking at the future correction ranges. Again, one correction range is simplest. I don't like to have more than basically two, kind of a nighttime and a daytime, because you can kind of tell loop to do what you want it to do, defining two ranges. So
Okay, so basically the 6 hours that you're talking about only applies to the correction range. So you put on an override, you're going to be stuck with that correction range for 6 hours, but it doesn't mean anything else. Okay, it's 6 hours long. Okay.
yeah,
good.
it's just saying
Thank you.
everything, whether we're talking about the future or now, an override is overriding. It's like, it's all the things. It's whatever it is, this is the number. It's not looking at the future and other settings. It's whatever you've defined or not in that temporary
Okay.
override time. Yeah.
Okay, thank you. Wow, that's interesting.
It's detailed, probably more than I was expecting to get into, but there you go.
Well,
Any
it's
other
clarifying.
any other questions before we move to, I forget who it was that was asking the question, but
Me, Meredith. It's okay.
Meredith, okay.
Okay.
Anybody else? Then we're gonna help Meredith.
Okay. So
All
I
right,
just
Meredith, you're up.
I have a question about roller coasting.
Okay.
So, my first roller coaster this morning was an obvious, my pump came out. So, yeah, it happened. But what puzzled me was it finally went down to 80. I was happy. And I ate some protein. I did cover it slightly, not right away. And all of a sudden, my sugar is back up to 300. And it eventually came back down on its own. But I'm just curious what the pump was doing. I don't even remember if I was. Now I know that there's a. I really appreciate that that autocorrect is not something that the loop is going to give me unless I do it, because I've been thinking all along I'm just doing it before it's ready to do it. So
Yeah, loop will do it, like we said, whenever the prediction and everything lines up to where you're in or above your correction range, then loop can start giving you insulin if you're in closed loop. But
I just
before that,
yeah, I can't figure out why that second
mhm.
um
So the second wave, if I had to guess, and we're not looking at a picture or anything, but if I had to guess, is that you mentioned the pump came out. So likely there was not as much insulin on board, or active insulin, as Loop likes to call it, is what it thought. Loop might have said, you had 6 units on board, but you probably only got, let's say, 3, because like the other
I
3
did
were
give
leaking
myself
out
3 units of insulin by shot, by
by shot.
injection,
Okay.
because I knew
Yes,
that there had to have been
that
something
helps.
missing. Yeah.
Yeah, so that helps balance it out. But essentially, the main reason why that might occur is assuming, again, we're making an assumption that your settings are relatively accurate. It's just the problem was the pump came out. That the amount of insulin on board wasn't what Loop thought, and the amount of carbs and or fat and protein weren't what Loop thought, right? So if you ate and didn't declare it, but you gave a shot to help balance out the insulin, then Loop might have needed to know about those carbs or protein, so that it could take the proper corrective action. Like, I don't know how much you ate in protein, but if you ate a whole bunch of stuff, then like, what did you have
I had a
to
can
eat?
of tuna fish with mayo.
Yeah, okay. Oh, with Maya. Okay, yeah. Did you put in any of that in Loop?
I I bolused .4.
But in terms of carbs, did you enter any
I
carbs
didn't
for that?
enter. I don't think I entered carbs for it. I'm not sure.
Yeah, so tuna
Yeah.
fish with mayo, that's undoubtedly going to need insulin in probably about an hour or hour and a half
Like
from
about
then.
an hour and a half later. Yeah.
Yeah. You're gonna need something. Loop needs to know, because otherwise, just taking a little bit of corrective action based on your sensitivity settings in Loop won't be enough to counter the lift you're gonna see from that particular meal. I mean, you're right. It wasn't a very
I
fast
should,
meal, so
right. I probably should have said that it was carbs. In other
yeah,
words.
you should have told Loop about some of those carbs or all of those carbs or whatever. Maybe a long meal, however you wanted to do it was fine, but it probably needed to know about some of those, so it could have taken a little more aggressive corrective action. So what I would do in those kinds of situations generally is okay. I injected what I think is probably a reasonable amount of insulin to kind of make up for what was leaking out, and we're eating. So I'm going to either enter all of it or most of it as I would normally do in loop. But I might, if I was a little tentative, I wasn't sure if it was going to overcorrect. This is where I would use a temporary override with a higher correction range, like maybe 130 or something along those lines. So then you'd be allowed to rise. You would have entered carbs. Loop would predict a high because you're not bolusing much. You only bolused a little, sounds like. And Loop might say, yep, you're going to go high. And maybe his recommendation was like 4 units or something like that. But you're like, I don't know how this is going to play out. I want to let it play out. If you raise the correction range, you're kind of giving that a space for Loop has to wait before it can give insulin. So you're letting the meal play out a little bit longer, right? So until you hit 130 in this particular situation, if you used a 130 override, then Loop would start giving insulin. But by that time, it might be like, oh, well, some of that meal is gone now, and it will give you even less than before, than it would have recommended when you first ate. So I always tell people to use a higher correction range in terms of an override if they want to let Loop like back off and play out or not add any more insulin. If you don't really want Loop to be involved in giving more insulin in this particular scenario, you want to pick a range that's higher than what you normally be using. So Loop has to wait, just like that scenario over Zoom. You want Loop to just turn on the basal and let things go before it chooses to jump in and help. So if that makes sense.
So if my range is normally like 100 to 120 and you're saying 130, are
You
you
might do 150 or something like that.
saying 130 to 150? Are you saying just
Yeah, that would be
150 to
fine.
130?
You just pick a number that you think, okay, if I get up to this number, I'm okay with Loop giving me more insulin. That's probably a more appropriate way of thinking about it. So if you were 80 and you ate and you entered the carbs and you didn't want to bolus much, which was fine, you're like, okay, I don't want Loop to give me insulin until I hit 150 because I want to make sure I'm not going to go low again or whatever. Then set a range for 150 for like an hour or two or however long you think you want to be, before you'll feel safe thinking that, okay, Loop probably has a better picture of what's happening now that I've had this leaking pod and I've given an injection, and you kind of want to let it play out for a couple hours. That's what you would do. So you might choose to give insulin before that, but if you don't want Loop doing it,
Yeah.
then
I
yeah.
was shocked that it went above 300 and probably maybe I needed to correct more for the protein than I did.
Yeah,
So,
exactly.
Meredith, so Phil had your lunch today. He had a half a tomato with a can of tuna, mayonnaise, and he also had some relish. 50 grams of carb is what Loop saw. 50.
Yeah, it's
Counted
it's
for
a
50 grams?
50 grams. So that's a combination of, carbs, fats, and proteins. 50 grams is what it saw.
even though
Okay.
it might only be,
I
12 or
just
15 grams for the bread.
Right. I'm very sensitive and I tend to underestimate my carbs to begin with, let alone my protein. But thank you
Yeah.
both. Yeah.
Yeah. So I would, again, my approach is typically enter the food relatively accurately and just set a higher range if you want to be conservative about when Loop starts to engage insulin. But if you enter the carbs, Loop will give more insulin than it would if you entered 0 carbs, which is what you did this time. So
Right.
yeah,
Okay.
it is an uncertain situation you're in when you have a leaking pod.
That's an
So
important point, though, Kenny. Do you want to talk about the fact that if you run out of carbs, Loop is thinking 6 hours out using ISF, which is a lifetime.
yeah, you're talking about 6 hours out in terms of like what you need to
When you
correct.
don't record carbs, you eat carbs and you don't record them.
Yeah. So
Protein-
typically with a relatively accurate ISF, at least one that's working fairly well for helping you with Loop tracking carb absorption most of the time, if you don't enter carbs, the correction amount that Loop will calculate that you'll need will not be anywhere near what you need to combat carbs. It's just the reality of it. For example, my daughter's ISF's around like 165. So if we miss on a couple of carbs, we're 5 carbs short, Loops might give a little bit of correction as she starts to go higher than expected, but it's going to be like 0.05, 0.1. But really what she needs is like a half a unit because she's like a 10-to-1, not quite a 10-to-1, but around a 10-to-1 carb ratio for purposes of illustration. She will need like a half a unit at least just to properly cover that meal and probably a little bit more. So it's just not going to be enough. So declaring carbs is definitely vastly superior to trying to hope that the ISF, which is basically all that's left if there's no carbs, there is enough. Speaking of which, what the heck? Yeah. Hope that kind of makes sense.
So Kenny, let's.
So
make
as we're
that-
getting late tonight, do we want to ask anybody who hasn't asked a question, or are there any burning questions? So we can kind of wrap up in the next 10 minutes or so. We all want to hear what Kenny has to say. I love hearing what Kenny has to say.
You can just hear
I
what Carol
think
has to say.
Here
I
on
think
the East
we,
Coast.
I think we close this down because we said it was an hour, and let's kind of stick to that because people had to learn a lot tonight. It's a lot to take in. So we take you in bite sizes, Kenny.
All right. Sounds good. If you guys have any more questions, you definitely can post on my comment on my post in the group about this particular event. If something that came up tonight or the topic we covered initially, go ahead and post your comments there. Or you guys can post anytime in the group. It's not a big deal. We do encourage you to search Loop Docs, search the group, but you're welcome to post if you have a question. So don't feel like you have to hide in the background and wait for someone else to answer a question or ask a question. All right. I guess that's a wrap. We'll talk to you guys later. Hopefully we'll come up with more topics, but I hope this is helpful. We'll probably try to edit this, throw it up on YouTube for now. It'd be better to, we'll try to get a more consolidated version of this at some point in the future. Thank you guys for giving me your feedback so we knew what points to clarify. So hopefully we can make a more polished video in the future. So it's always helpful to get the real-time feedback of like, what? So
Thank you, Kenny. As always,
Thank you.
outstanding. Thank you,
Nice
thank you.
job.
All right.
Thank you.
Good night, everybody.
Thank you so much. That was really amazing.